Alright, another draft physics video presentation. Very frustrating, okay, and so, it is difficult to have these conversations without getting angry, because it's all, you know, you're like, oh, I shouldn't have to go all the way back to the beginning and start all over and explain everything. But this happens with a lot of subjects. You can almost argue in politics this happens. You have to kind of go back and explain to people, how Jefferson's principles work, like your rights end where another person's rights begin, and then you try to work your way up to some more complex ideas about the give and take required to have something called a civilization and blah, 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 blah. So, it happens all over the place, and people want simple answers. They're very knee jerky. They're very monkey see, monkey do, monkey say, monkey repeat. And so, yeah, it's difficult trying to explain that you've seen something, you have knowledge of it, you've been there and done that. And somebody who hasn't been there and done that is just saying, nah, that ain't how it happens. And they won't really realize until they fall into the trap, and or they, whatever the circumstances is, they gain a little bit of knowledge. And so that's what all this is made out of, is this fact that humans are in different perspectives in terms of how much they've seen or what they have seen, how much they've touched electricity, or how many books they've read and what kind of books they read. Was it the books that explained how the experiment done, or was it a book explaining what the experiment says? Lots of variance in our knowledge bases and our where you're coming from, and we have to try first to have some sort of common vocabulary, agree on what certain words mean, and and then the rest of it is just this grinding about. There has to be at some point where you just say, yeah, look, I can't teach you how to play the piano, right? I know how to play the piano because I played the piano. I've done it. I did the work. And somebody else hasn't. I can't just make them smart enough to play the piano. I can't give them the knowledge I've acquired by hitting the keys the wrong way and figuring out how to hit them the right way. Not that I play the piano, don't get me wrong. I'm just saying that we all, there's a point where, there's just people who are belligerent and say, I'm a very good driver, even though they've never driven. I can do it. I know it. I understand, when they haven't done the preliminary work required to understand. And that's a huge problem, and it's a huge waste of time if you start getting into arguments with people who have that vastly different experience. It's like some kid with a Betty Crocker, easy bake medical kit or something, having an argument with a doctor or something. It's just, there's a certain point where it becomes a little bit ludicrous. But anyway, so there's got to be some agreement about, if somebody's going to make assertions or claims, they can't just be based on their non-existent authority. They don't have a degree. They don't have evidence that they really know the subject. They're just making declarations. This is how it is. That's not good enough. All right, anyway. So this Robert Ritchie guy, who ultimately I'll play a video of, and I appreciate they made a video, but I can't say that the content is what's required for again, it's just more declarations without evidence. Gary, do you agree or disagree with the following statement? So again, let's pigeonhole everybody, but whatever. Photons and radio waves are two separate yet related entities. As I said, it's too mushy a statement. I'm obviously arguing they're the same damn thing, fundamentally, but they're created through a subtly different mechanism. So I guess I'll illustrate that while I'm here. So yes, I've pointed out where, look, we don't agree. on these underlying premises. I'd say there's no evidence whatsoever that these things are waves, especially a standing wave, which doesn't make any sense at all. They're corpuscles. They're energy moving. They hit things like little rocks, okay, much like that. Rocks that stick. So the energy doesn't get destroyed. The rock hits you, it sticks to you, and then someday you can give the rock back going the speed of light. But as long as it's stuck to you, you're stuck with its momentum. So as I've pointed out, this is my description of what's called a photon. So these single little dots are not photons. The ray is interpreted as what we call a photon, and it has these elements in it, and the elements are at a specific distance from each other and at a constant speed. That means they're at a specific frequency, that there's a specific amount of time. Time and distance are the same thing when there's a constant speed. And all of these things move at the same speed. And so the only difference between this, which we could say is red light, let's say, and this, which we could call a bit of microwave, is the fact of this distance. This is the only thing that makes them any different. The stuff, the quanta, is exactly the same, and all you've changed is how frequently it's going to hit a surface in a period of time. I do have a propensity not to get things into complete view. And I don't think there's any experiment in the known world that demonstrates this can't be the right answer. I think it's the Occam's razor simplest answer. I think it explains the phenomenon quite completely, and it is what we observe. Photons travel a straight line. They're not bent by any forces, and when they arrive at a surface, they arrive at a tiny, 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 tiny location and affect a tiny, tiny, tiny location. That's what we see them do. And radio waves are the same thing, and the only difference is how they're created. Now the photons are at a much higher frequency, and the trick is that means that a single atom with probably a single electron is creating the photon. So the photon is an action that the atoms themselves, the individual atoms and the electron, create. And I would argue it's created by the fact that the electron is pressurized, and when it depressurizes, okay, so it's pressurized, let's say, by electric voltage, and the electric voltage is much the same as this force, except you don't have to worry about the frequency. It's just the pressure of it. So these little bits are pushing through a wire, and as they push through the wire, they create pressure in these electrons, and when these electrons pop, so to speak, when the pressure escapes, it escapes in this regular manner, because that's exactly how they decelerate. They decelerate in a regular pattern, and it ejects this electric energy that went in, ends up coming out as this photonic energy. And we see it as a bit of light. Now we see that these single electrons, single atoms, can produce a variety of kinds of radiation, all the high band radiation, X-rays, stuff like that. It's being created by single atoms. Now when we create a radio wave, we're going to do the same thing. We're going to use a voltage, so we're going to use little bits, little pressure bits, moving the speed of light that are traveling through a medium. So they're not moving the speed of light while they're going through the medium, but close to it. And we're going to jiggle not just one atom, we're going to affect all bunch of atoms. So instead of making one atom create a whole ray, we're just going to tell a whole bunch of atoms to pressurize and then depressurize, and they're each going to create one little photonic bit. And then when we hit them with another jolt of voltage, they'll make another row of little bits. So we are creating the frequency. So a radio wave is entirely a man-made, so to speak, frequency. We impose it on the energy, the gravity, you could say. You could say these little bits are gravity, and I'd be perfectly happy. Or you could say they were magnetism, and I'd be perfectly happy. But that's what they represent. But they're also the same thing that went into the wire. They're electricity. They're the pressure, the voltage of electricity is what's coming out of the antenna as these little bits of energy. And so the difference between light and radio waves is just that light at the high frequencies is created by a single electron, so it has a real tiny point source, and the radio waves aren't point source. They sort of are point source. Each atom is creating a row of them, so it is. But clearly, radio waves can, the ray you can make with radio waves could be very, 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 very long, very consistent, where you're not likely to be able to create a perfect ray of light like that. The ability to do this to an electron, you're going to have to recharge the electron to have it shoot another ray. So rays of photons will be of limited size. But that's fundamentally the only difference, is essentially how you create them. And that's it. But it's just force at distance. It's just a cannonball's bullets fired at a frequency. And we perceive them when a certain number of them hit our devices. We say, there is something. But it always has to be a certain number. We don't have any device that can see just one of these things. The only devices we have, they have to see the frequency. If they don't see the frequency, they don't see anything. They're all frequency dependent because they're all requiring an electron to create a voltage. And the electron will only create a voltage if you hit it with enough energy. Without enough energy, it does nothing. Nothing's going to happen that we can detect. But it doesn't mean it's not there. And I would argue that light polarization gives us a clue to this, because half the light is actually being blocked by the polarizing film when you send in mixed polarization light, non-polarized. 50% of it won't get through, and more than 50 by my theory. A little bit more, because some of the light going the right way doesn't get through because it hits the bars. But anyway, and yet no one's done any analysis to say, well, why aren't these films subject to melting very easy or getting hot? There's been no evidence that any of that stuff happens. So where does the energy go? And I think a rational argument could be made. The energy passes through the filter, but it's now broken. It's lost its consistency of its frequency and now been turned into small rays. So where before it was a ray of, say, 6 little bits, it's now, a ray of 2 and a ray of 2 or 3, and it's just not enough energy to do what it needs to do to the electron to create the electron reaction of creating a voltage. Need that in the picture there, don't I? Sorry about that. I think you get the picture. So that's my answer to the question. Frankly, like I said, it's a question that doesn't, it's just such a mushy ground. It's like saying, it's like when people say there is no such thing as race or something. Obviously, there's something called race, and when they say there's no such thing as sex, female and male, well, of course there is. These are kind of stupid things to say. So, yeah, but obviously you wouldn't say it's a major difference, right? I mean, we're more equally human, than we are different. The tiny bit of us that is the difference is a tiny bit of the whole machine. So yes, you'd say they're the same thing fundamentally, but the differences are really important. So, you don't discount them. So I'm saying, yes, they're the same exact stuff once they're in the air and they're moving. But they're not the same thing in how they're created or caused. Now, the other thing that he's going to bring up is the inverse square law, so I thought I'd just do a quick shot at that. And both of these things travel that way just because of the way an antenna works. So as I pointed out before, if you were looking down at an antenna, okay, so you're looking down from the top, So it's the top of the antenna, and say this is the bottom of the antenna. And so it's this long antenna. The rays are coming out this way, and they're coming out in planes. Okay, so all the way up the antenna. So all the way up the antenna, the rays are coming out this way, and all the polarization is in line this way. So the lines are all red, black, red, black, red, black, going around from each ray that are coming out. So there are rules about how the radiation is expelled by the antenna. But the key thing to understand is the divergence is the same principle. Okay, the photon that leaves the electron, the angles they can leave at are 360 degrees. I mean, spherical, half circle, so they're 180 degrees all the way this way and all the way this way. So they can leave at any one of those angles, which means that's the inverse square law. So if they could only go this way, then you just say it was an R law, because it can just spread this way. But because they can spread both ways, okay, that's the inverse square law, because now you've created a bigger area. All right, so that's the square part. And the same thing is true for this visual effect. So, I mean, I keep doing this, but I just go half the distance, and this thing is 4 times bigger. Now, it isn't 4 times bigger, okay? The trick is your point of view is 4 times smaller. See, what happens, because it's pointing source, it's coming from one angle. You're not viewing something on like some big giant piece of film on one end of the universe and a big giant piece of film the same size you're viewing on the other side of the universe. And you're not watching the rays going parallel. Everything has to go through little pupils, little holes. And that little hole creates the idea of a point of perspective that's growing in both dimensions. It's 2-dimensionally growing. And that's the inverse square law. So the thing that makes this hand change size isn't the hand changing size. It's the fact that its percentage of your point of view is changed. Okay, so here the hand owns, half the point of view, the perspective. And here it only owns 1/4, because now the point of view, the area of your viewing area, has increased by the inverse square law. And so that's what makes the hand look different, is because the viewing area it's being looked at in is now huge compared to what it was here. And that's the origin of the inverse square law. It doesn't need explanation. This is its explanation. Okay, these diverging lines are its explanation. They're diverging this way, and they're diverging this way. And that's your square. Okay, that's the inverse square law. And it has to do with point sources and the idea that perspective increases in both dimensions. Okay. Yeah, I think I did enough of that. I think I did enough with that. Just saying that I can cite I can cite a simple experiments to prove the point. Simple experiments. It's quite solid physics. All right. So Superior Mind said, personally, the only way which it interacts with matter that is different, which has more to do with how matter works. Yeah, it just has to do with the fact that electrons, as I've sort of pointed out, they have a tension, and they have what could be considered resonance frequencies. But more importantly, they have a speed, a rebound speed. And so you're really just talking about, it's like you're trying to wobble something by hitting it with baseballs or something, a stick, and you're trying to make it wobble. you know you have to get the momentum in the right direction. You can't try to hit it when it's moving the wrong way, or you'll just destroy the energy you're putting in a bunch of heat and friction and other kinds of crap that you don't want. So if you want to add to its energy, you have to always add it when it's moving the right direction. And that's why electrons are frequency dependent, is that frankly you have to have energy of a high frequency going in, because the electron will bounce back if your energy is too slow. So if your energy is too slow, it hits, the bullet hits, it pushes the electron, and then the electron moves back before the next bullet gets there. So infrared doesn't pop electrons free off the surface of metal, because infrared lets the electron start moving back. And once it starts moving back, then you're not constructively adding to its energy. So only at a high frequency do you constructively add to its energy, and therefore create the potential for the release of the cascade of photons, of quanta, that will be called a photon. Alright, if you move towards the radio waves quickly, you blue shift them, and the interaction will be different. Yes, true with both radio and light and anything, just really anything moving. If you move towards anything that's moving towards you, you in a sense will blue shift it one way or another. Whether it's perceivable or not is another question, but you will create some change. Alright. So Superior Mind says that fallacy-laden troll video is almost impossible to decipher. Yeah, well, I wouldn't know because I didn't watch it. So, it's just too pathetic. The joke is the video itself. The experiments clearly have some holes. Clearly these experiments, as described, have more than just holes. They have they're making conflicting claims about the nature of quantum mechanics. Again, they really have to figure out whether they think different photons can interact with each other, or whether it has to be an individual photon that splits into a wave function and interferes with itself. They really should get this stuff down, because frankly those two statements are almost as bad. Yeah, well, it's a duality you have to fix. You can't just claim there's two different mechanisms that end up with the same result and account for neither one of them and not point out why it doesn't work. I mean, why can't I shoot the red laser into the blue laser and create a whole bunch of flying photons all over the place? Interference tons. Alright, Bob the Fly. So, this is just so annoying. But anyway, I will try to keep my temper. At 8:10, you asked me to tell you what you can calculate. Yes, and I gave examples. The inverse square law, as I just pointed out, is rock solid. It doesn't need any calculating. We don't need to figure out what causes it. As I already explained, we've already figured it out. It's not an issue. It doesn't need redefinition. They're saying bent space is causing the effect. That's what's at issue. What you can calculate is the amount of force that particles hit the Earth. Again, why would I go to the Earth when this is gravity right here in front of me? The same particles that are moving the Earth into the sun are hitting this battery and moving it to my hand. Same exact particles, no different. Same shit. No different. Same thing. Why would I go outside the Earth and try to collect energy outside the Earth when it's right here in front of me? Can you explain that to me? Particles hit the Earth on a daily basis, and what models show the effect should be. So again, saying the word particles doesn't serve any purpose at all. Clearly, they use words like particles. Are you saying what, Volkswagens and electrons and photons are all particles? Obviously, when I use the word particles, I'm talking about these little bits, okay? And clearly, when I say 90% of the time, let's say, I make a clear distinction between a matter bit and an energy bit. A bit moving the speed of light and a bit not moving the speed of light. They're different things. If it's a material bit moving, it's moving because it has a force in it. It has momentum that it acquired through an event where force was injected into it. Somewhere in its past, something hit it, and is now inside of it, is now owned by it, is now caught inside of it. How many times do I have to make this clear? Force is not matter. Particle is not particle. So this is just useless rhetoric. Anyway. On the basis what models would show the effect would be. So again, I really don't know what he's even thinking about here. It's so distant from understanding that we're talking about an ultra mundane force that is in the form of photons. If the observed effect is different, then we know that either the theory is wrong or that there are unobserved particles. I don't know how you can prove that. Again, I mean, I'm saying right now it's quite obvious that these are unobserved. Whatever's doing this, it's unobserved. We don't have any way to detect it except to do this. Look, I put this here and it moves. Their explanation is there's some kind of geometry thing that makes it happen. Who knows? Voodoo, whatever, sliding vagina, it just slides in somehow. There's goo, it's slippery. What? Nothing. They got nothing. I'm giving you a rational explanation for what's causing this to move. There's a force in the universe everywhere. And it will cause every single object in the universe that has little matter bits in it for those matter bits to eventually go spherical. So like if you made an asteroid really big, it would start to go rounder and rounder and rounder and rounder because its own mass would force it to do that by this simple inverse square law. The inverse square law would force it to go round. And that's what we see all around us, isn't it? Oh, there's a whole nother subject on this round thing that I thought of. So maybe I'll talk about that. Maybe I'll do it right in the middle of this comment. That'll ease the pain a little. Sorry, my back is just still so bad. Oh. Anyway, it's all on one side now mostly, but anyway. Exhausting. All right, so I was thinking, the orbits in the solar system are all ellipses. Now, and that's sort of one of Newton's laws, that orbits are always ellipses. Well, it's sort of not a law, okay? And you can sort of understand why it is. Because things that are going to get captured would always have to be in an ellipse, right? Because the odds of the thing, well, frankly, there's no probability. It is, in fact, impossible, okay, for something to come from the external universe. Drawing, please. Okay. So it really is, as a practical fact, impossible for something to come from the external universe, and because of the gravitational pull of the body, there's no angle it can come into or velocity it can come into where it would end up in a perfect orbit, a round orbit. It can't do that because it would always end up with too much speed. So the only way it can have anything like a round orbit is it has to hit something. So the thing coming in has to hit another thing to slow it down, to get the orbit to be anything close to round. So the real case scenario is this stuff comes in, it gets gravitationally pulled, and it ends up in some sort of ellipse because of the fact that it came in, it's going to have too much speed, and and then it's going to also have to hit something, frankly. But yeah, there's just no chance of having the round orbit. But when we look at galaxies, right? So this is another argument I'll make in my defense of my theory of galaxies. Is galaxies are very elliptical. Galaxies are very symmetrical, spherical, lots of round galaxies, very round galaxies, indicating that the orbit, like with Saturn's rings, you could almost argue Saturn's rings are pretty non-elliptical, pretty damn straight, that they had to come from the surface. that's the only way they could have that perfect orbit, is that they have to be something expelled by the body itself. And that's why they have round orbits instead of elliptical orbits. So it's sort of a giveaway. So when two things are in a orbital pattern that is elliptical or imbalanced, it's an indication that they did come from the outside world and interact with each other. Again, but they had to hit two things. They had to hit something first, because if they don't hit something, see, the rule of gravity really is that there's only two things that will happen when you come from the outside. No matter what your speed is, you'll either crash right into the object, or you'll just get bent by it and you'll leave. Those are the only two events that can really happen. And the only way you can get captured is you really do have to hit something to get slowed down. Because if you don't get slowed down, you're not going to stay here. But that's a fact nobody tells you. So you heard it here. And it's unfortunate that they really don't talk about it, but orbits are not that easy. And they do have to be manufactured by extra circumstance, because there's just too much energy. So the thing coming in is constantly accelerating. So even if it's coming at a wrong angle, it'll just keep bending right towards the object. And so if it's going too fast to bend into it, that means it'll just miss. It'll fly back out. And if it's going slow enough to bend right into it, it'll go bend right into it. It'll hit it. It won't miss. It'll find it and hit it. Because the gravity the whole time is bending it right towards it. It's saying, please come right to me. That's what it's going to do. All right. So anyway, back to the crap. I mean stuff. I mean the charming commenters, for whom my life would be so empty without. All right, hit the Earth on a daily basis, and what models show. So again, whatever the effect should be. They modeling whatever you're calling a particle is irrelevant. If you're going to say they can model radiation we can't see, so again, I'll just keep pointing out, there's a force that's moving this battery. I say it's as real as photons. I say it's as real as light or radio waves or any other force that moves stuff. So all the forces we see in the real world that move stuff, the force doing this to this battery, okay, is exactly the same kind of force. And the fact is, it is in a form. We can't just put some device with a little crystal and say, I can detect the force that's moving this battery. We can't detect it, because the only way we can detect the force is we have to have it do a specific thing to an electron to create a voltage in a wire. And if the force doesn't create a voltage in a wire, we can't detect it. But it's there. It's real. It's made of the same crap that a light photon is made out of. Alright, if the observed effect is different than we know, either the theory or is wrong, or that there are unobserved particles. Well, clearly I'm arguing there's clearly unobserved particles, which couldn't conform without math. Well, again, there's no math because it's a conservative force. So, see, that's the catch of it, right? You can pretend there's no force, because you can say the energy goes in, and then you know that the only way this battery gets out is you have to apply the equal amount of energy to get it back up here again. Okay, so to get it over here, you're gonna have to do as much work as the work that this was. So the energy you got, or the energy you used, will be the same as the energy used to get it out of gravity. So the fact that it's conservative means they don't really have to account for it. Nobody has to account for it. But clearly I'm arguing that the force is the same force that's creating magnetism. So obviously now you can explain where the force of magnetism comes from, because the same force that's doing gravity does magnetism. All you do is segregate the force for the plus force and the minus force. And now you have a magnet. So I'm just saying it's clear that the force has implications. It's clear that the center of the Earth is hot. Okay? And where's that heat coming from? Well, it's coming from the fact that there's a battery going this way on this side of the Earth, and there's a battery going the other way on the other side of the Earth, and those conflicting motions are going to create heat, because those are real forces, real energy, and that energy is going to cause a conflict, and that conflict is going to create heat, and it's going to take time for that radiation to finally escape. but it will. But there's a certain amount of it stored as potential in the earth. And that means there's a certain amount of energy that didn't get where it was going because it's caught inside the earth, making it hot. So while the energy is making the earth hot, it's not getting where it should have gone. And that thing is saying, nothing's hitting me, because the energy is making the earth hot. It's not hitting this thing, and that this thing is saying, I'm going to go this way because there's more energy pushing me one way than the other way, because that thing absorbed the energy that would have hit me. Really not that complicated. And again, there's a certain obligation here. I've explained over and over again. You have your own agenda. Maybe you have your own theory. I'm really not here to debunk you. And clearly, if our theories aren't compatible, then there's not much use we're going to have for each other. My objective is to point out how conventional physics is unevidenced, that their evidence is insanely weak, preposterously weak, and they've made bold claims about how the universe is made that are made out of just mushy statements that they might as well say the invisible man did it, God did it. They might as well just say mush did it. They might as well say I did it. They might as well say I caused gravity, as to say something like geometry did it. It's a vacant answer. It has nothing to do with a physical explanation. And when they call magnetism a virtual photon, it's an empty answer. It's nothing. It's saying absolutely nothing. And people should be wanting a real explanation. Something real. Something you can draw on a piece of paper. All right. That's my objective. I'm just not here to confirm or refute your ether theories. All right. And confirm the math, because the math allows you to try to predict what should happen, assuming your model is correct. So again, there's no math here that's going to be able to prove there's a force hitting this battery. It's not a mathematical problem. It's a detection problem. It's a problem that we don't have a mechanism for detecting this force. Again, it took Hertz. He knew radio waves existed, and it took him 7 years to figure out how to even detect them. So come on, it's not that easy. All right. So, Hoffaday, weird statement. How's your health generally? Well, as I've pointed out my whole life, I've found life to be rather nauseating and revolting. But yes, obviously I'm physically not too bad. Noticed a bit of a cough. I don't know where you noticed that. Frankly, I sneezed last night, and the pain was insane, because of my back. So if I had a cough, I'd be in big trouble. So it's a good thing I really don't. I have a mucus issue, like some people do, so I have to clear my throat now and then, but that's about it. I don't know how to say this, but my paps went out with the big C with these symptoms. These symptoms of what? Looking generally pretty healthy and having to clear your throat once in a while. Yeah, I don't know. Maybe I have no, there's going to be some kind of horrible thing that's going to kill me. Yeah, so everybody's going to doomed, and maybe I already got it. Maybe there's a big giant tumor and all that shit's happening right now, and it's just terrible. Life sucks. I mean, I got nothing nice to say about this silly game. So yeah, I got nothing. But yes, I don't notice anything immediately wrong, except for the heart attack I had last month. Minor, but yeah, just. I have a bad valve in my heart, and so the theory is every now and then a little crappy clot goes from the arterial flow, the venal flow, and it leaks into the arterial flow, and it either goes, because it's in the carotid thingy, it either goes right to my brain or it goes right to my heart. So every now and then a little tiny clot either gives me a stroke or fucking a heart attack. Now life's fun. I love it. Love it. It's just so much fun. Anyway. We men are so reluctant to go see a doctor. Well, actually, I love doctors. Fun. Especially when they make house calls. Then it's really good stuff. But yeah, no, I'm really not afraid of doctors. I love a nice shot of B12 or something. Give you a little perk. It's okay with me. I hope I'm being silly. It's concern for somebody else's health is a very nice thing. I'd be the last person to call that silly. Um, yeah, I just think your speculation. I mean, there's people who look a lot worse than I am. Oh, yeah. So, I'm probably not. But I think this bad back thing has got me worried. Like, oh, is this the one that's never going to get better? Because I can't afford to be like this for the rest of my life. All right. Do you remember my last comment asking you if you liked it? Yes, I saw that, and I said, "What the hell is this guy talking about?" A very strange thing, to talk about down bots in some way. So anyway, so this guy apparently has a very poor opinion of Holiday, and I don't know why. I mean, Holiday is infinitely dislikable for lots of reasons, but I'm just saying we all are. And yeah, I despise his nihilism. I despise things about him, but I really don't think he wastes too much of his time on Earth doing little troll shit. Yeah, I just don't see how you think he's the kind of guy who just goes around going, "Oh, I'm going to downvote that." Yeah, I don't think he wastes his time with that shit. I was referring to the fact that you seem to be enjoying all of the downvotes. So Robert, I mean, it's nothing personal, but yeah, I think your perception is a little bit bent. Okay, so maybe you gotta, be a little careful, because I think you're seeing things a little bit crooked. I have watched some of your videos, and it is sad, just sad. So again, I really don't know what you're seeing in his videos. He's an obnoxious, arrogant turd, like all of us. I mean, is there someone who isn't preposterously almost arrogant? Please show me the non-arrogant folks on the YouTubes. Now you are here like some demented vulture. So again, I think he was pointing out how, gee, that's really sucks the way, your video just got downvoted for, 60 downvotes and there's only 30 views on the video. That's retarded. Yes, Holiday, you are being silly. So again, I don't like people that enjoy others' misfortune. So again, I think you're just really misinterpreting. I don't think he enjoys other people's misfortune. He just tries to ignore it. So, and his own kind of mechanism, survival mechanism, whatever it is, he's in some way figured out that other people aren't real. Don't have to worry about them because you don't, it's not happening in your brain, so therefore you have no evidence it's a real thing in the universe or some kind of shit like that. So yes, he lacks normal empathy capacities. I think it's more demented than that, but whatever. It might as well be a psycho killer. But regardless, I don't think he's a malicious one. He might go on killing rampages, but I don't think he's doing it because of some sort of anger issue. All right, Robert Ritchie. Hi, Gary. Made a video. So here's the video. Okay, so we'll go to the video. And I guess I'll play it, but it's void of content, which is a problem. So you can see it has 60 downvotes. So obviously, I don't know what this really is. It seems kind of weird that the trolls would hate the Robert Ritchie guy as much as they hate me, because we're arguing for a completely different world. So that doesn't make much sense. Maybe he downvotes his own videos. I don't know. I mean, I shouldn't accuse him of some kind of subversion, because that's not fair. It just is bizarre.
Hi, viewers.
61 downvotes. 61. 68 views. I don't even know how they do that. Obviously, the view number is always lagging, so I guess that's the reason it happens that way. So I'm basically the only person that's watched the video, and the troll has put 60 downvotes on it. And for what reason? It escapes any kind of, why is that happening? Where's somebody getting all the energy to downvote a video that, and frankly, the guy doesn't, I don't think he has any subscribers, right? Subscribe, let's see how many subscribers. I don't think he has any. He has one now. I don't know how many he has. Let's go find out. Doesn't say. Well, then I can't tell. It doesn't say. Let's see. I wonder if it says on the home page. 8,000 views. So he's got something. It's been here for a long time. 10 years. But I don't think it says how many subscribers now. So I guess he must be hiding that data or something for some reason. He doesn't have any recommended channels. Let's see if there's any on that. No, doesn't do any of that stuff either. We ought to do a channel exchange anyway. So I was thinking about that at minimum, I should offer to people, you know, my list of recommended channels, and we'll do an exchange. You put me on your recommended list, I'll put you on my recommended list. And there'll have to be some rules about popularity and stuff in terms of the exchange. If, you know, if my channel is much more popular than yours, maybe you put me at #1 and I put you at #5, something like that. But we can work that crap out, I would imagine. But might as well use the mechanism. I don't know how much it helps, but we got to do something to get views. That's for sure. So anyway, let's play this. Sorry, I'm going to say crap because it's crap. I might as well make it big.
Well, let's talk about the electromagnetic universe and also the difference between a photon and a radio wave. Here we say energy is comprised of two parts. You can't have one without the other. Electric field and a magnetic field.
Alright, so obviously I totally disagree, and I don't think there's any evidence for two fields existing, or any fields existing. There's stuff moving at the speed of light, and it has a frequency, sometimes. And it doesn't necessarily have to have a frequency. And that's how I view it. They're corpuscles, but they always land in tiny, tiny, tiny locations. They always land as a little tiny pixel somewhere. They don't land as a wave somewhere. They obviously look like spray paint, you know what I mean? Little tiny dots flying out. There's no real evidence of anything waving. They don't say I'm waving paint onto a surface. What do you see that makes you think the paint can is shooting waves?
Mass, motion, force, everything's just combinations of these. And mass...
Yeah, I know, but that doesn't mean anything. Mass is a thing where we have matter versus force. Now, the forces obviously are moving the speed of light, right? Magnetism, you know that's moving the speed of light. Gravity's moving the speed of light, and light's moving the speed of light. So the entire electromagnetic spectrum is moving the speed of light. It's the speed of force. And the force bits have this perpetual motion. They go forever. You can't kill the photon's energy. And you'll always see, when you see the energy, it's always going to be in the form of a photon. Even when it's making heat, right? We see it as infrared radiation. So by the time it gets out of the object, it's back in the form of a photon again. So even when photons go into something and they might not look like photons anymore, we know whenever they come the hell back out, moving the speed of light, they're going to come back out as a photon again, or something they call a virtual photon.
Energy are interchangeable, as are...
Mass and energy are interchangeable. Again, they're not interchangeable. Matter is fundamentally different than energy. Matter traps energy. Matter bits, the electrons, protons, and atoms, they have energy between them, holding the atom together. So they store energy. Matter creates batteries. Batteries hold the energy.
Magnetic field and the electric field.
So you said again, doesn't mean a damn thing. There's no pictures of these fields. There's no evidence that they exist. There's no experiment that shows them to exist. And there's certainly no experiment that shows there's any distinction between the electric one and the magnetic one, except for the fact that one's a monopole field and one's a dipole field. And obviously there's a difference. I mean, I've explained this, but I'll give you a quickie. If I have a dipole, okay, if I have two monopoles separated by distance, okay, two different polar things, their radiation has the opposite effect. So let's just say one of them is shooting out stuff that says come towards me, and one is shooting out stuff go away from me. Now if I keep them far enough away, you'll feel them as, wow, this one's all go away. And you'll feel over here, oh, this one's all come towards me. Now, if I shove them right next to each other, you can see the dilemma, right? Because now it's come towards me, go away from me, right next to each other. So I'm just going to sense almost nothing, right? Because all I can sense is come towards me or go away from me. So from my perspective, this dipole thing looks like nothing, right? So that's the difference between a dipole and monopoles. And that's all there is. That's all there is. The electric field is always a monopole field, one thing at a time, and the magnetic field is describing what happens when you have dipoles, and more importantly, what you have when you have dipoles stacked on top of each other and therefore creating a magnet.
Just start with the radio waves and why they're not photons. And there is a frequency where an electromagnetic wave does become a photon. There is a sort of like a barrier there. It depends on a few things, but we won't get...
Yeah, so we won't get into that. Well, that seems a very important thing. You're saying there's some sort of fundamental difference. So when it's doing this, it's a whatever. So when they're a foot apart, it's radio, and when they're 6 centimeters apart, then it's somehow photon. No. They're shoes. They're punching bags. They're rats. They're at a frequency. The quantization experiments are just so abundant. The ones demonstrating the amount that this is a question of energy. And clearly there's more energy in things that are more tightly, more frequency. If I shoot the bullets every half second, in another gun I'm shooting just every second, I'm clearly going to shoot more bullets at the half second interval in 1 minute.
A little bit complicated. What we'll do here is we're looking at a radio transmitter, X megahertz, doesn't matter, standing wave ratio, and transverse electromagnetic waves, which are travelling waves. The first rule...
So again, you're just saying things, right? You're not showing me any evidence that these things are first a wave, that they're in any way transverse, that they have two components to them. None of this has been proven with any experiment. This is all just your speculation, your statements made because this is how you think you can fit the evidence. And as I pointed out, I don't think it fits the evidence at all, because that's not how the world interacts. As Richard Feynman says, it's not how the thing works. You can't make a photomultiplier do its job with this wave theory.
A standing wave does not transmit. That's what it does. It just stands on your
So again, this doesn't make any sense. A standing wave created by what? Standing waves are created by tension and reflection in a medium. So where is all of that in a photon flying through outer space? Where is that?
And it wastes power. The TEM waves, they're the ones that travel out into space. The problem with calling an electromagnetic wave a photon is at low frequency, these waves travel around the world.
So, again, that's not even true. All of these things travel in straight lines. They're photons. They're little bits, little corpuscles of energy. They travel in a dead straight line unless they hit something. Now, the key fact is that the long waves, that is long wave radio, doesn't go through stuff. It doesn't transmit through atmosphere very well. It doesn't transmit through things. Now, there's a disadvantage in that, that kills your energy, but the advantage is it reflects off of the atmosphere. So it reflects off the high atmosphere, and it reflects off the ground. So it can go halfway around the world, but it goes halfway around the world not by traveling a straight line, not by traveling a nice curve. It does so by bouncing, reflecting off of the objects, buildings, it will reflect off those. It reflects off things to get itself to the other side of the world. So reflectivity, the different reflectivity of light, the different opacity of substances is clearly known. Glass, for example. Visible light goes through it really well. Ultraviolet, not so well. Mica, can't put visible light through it very well, but you can do ultraviolet, goes right through it. So clearly different substances are permeable, invisible. They become transmission mediums, and different ones become reflections. So clearly metals, in the case of radio waves, are clearly reflectors. No transmission, through there's no, not transparent. Okay, very opaque.
Yeah, I'm not a flat earther. Got plenty of proof to laugh at that idea.
Understood, but again, you're making a whole bunch of statements, and I would argue they're not evidenced. And like the one you just made this vague notion that somehow the long-wave radio waves are doing something different than the rest of photons, that they're not traveling in a straight line, they're not doing all these things, when they are. I mean, I'm not saying something like I'm the only person saying this, okay? I mean, they've been knowing this for a long time, that the short wave works by bouncing off of surfaces. The long wave works.
Such as the distance of the moon, and I am an ex-ham radio operator like so many other people out there, and
so you should know all this then, right? I shouldn't have to explain to you that you know the radiation itself is moving in a straight line. It goes from point A to point B in a straight line. It doesn't wobble its way there. It doesn't go over here and then swing back over there and swing over there and swing someplace else. It doesn't do any of that crap.
I actually did do moon bounce years ago with a mate of mine, Jim, and we said hello and got a bit of a delay and then received a very faint hello back. So...
Right, so you demonstrate that some portion of the radiation you produced went in a straight line, some portion, one of the rays, went to the moon, bounced off the moon, all right, and came right the hell back to your little radio set, and you got a little hello, back. So why are we arguing this?
We'll look at a standard diagram. I'm sure you've all seen these before.
Yeah, standard crap, right, made up nonsense. This is just Maxwell's perversion of reality. He's a step unfinished in the sense of this stupid, idiotic notion that there's two kinds of a field. There's not two kinds of a field made out of two kinds of things. It's one thing. There's charge. Dipoles are magnetism. Single independent charges are charge, and that charge can be understood as the magnetic monopoles, especially when it's in the form of atoms and the proton and the electron. They are perfect correlators to the monopoles of magnetism. They explain it. And well, of course, like I said, to really understand, you need to understand that why are they charged? Well, they're charged because they are able to interpret two different forces two different ways. That's why they're charged. That's how they're doing something reciprocal. One reflects electron energy, and one reflects proton energy, and vice versa, absorbs the other. Not that complicated, not absorbs, but perpendicularly re-releases.
X-axis, the Y-axis, and the Z-axis. My question to all you clever people out there is, we see the electric field in the X-axis and the magnetic field in the Y-axis.
Yeah, complete made-up nonsense. Again, there's not a single experiment on Earth that demonstrates any of this stuff is necessary or real or any of this crap. It doesn't mean anything. It's just garbage. The only thing that changes in Maxwell's equations when you use an E field versus using a B field is whether or not it's an R squared, or R cubed. So I just explained why, this is the difference in Maxwell's E field and B field. Here's the difference. When I have these two things apart from each other, then they're E fielding, because the strength of the attraction and the strength of the repulsion is intact. And when I put them together, that's when I do the R cubed thing, because now this field doesn't mean anything unless I'm really damn close. The only way I can see that there's two things here is I have to be really close. From a distance, these two things disappear as meaning anything. They just all mix together. The pink and the green mix all together, and all you see is whatever pink and green equal, brown or something. And so you have to be close to be able to see it's green and it's pink. But as soon as you get a distance away, it's just brown. That's all Maxwell's equations do. They just change the fact that when you say E, then it can possibly be the R squared or it could be the R rule. But when it's a B field, well, then it's going to end up being R cubed.
Fields are always 90 degrees to each other. Now, your electric and magnetic fields must be in phase for TEM propagation. That's a simple rule, very simple.
So again, this TEM, whatever that means, and propagation. Again, it's a thing, moving the speed of light. It's a corpuscle, as Feynman would say. Again, I'll just keep using Feynman, but I mean, this is, I don't know what to say. This is just a fundamental disagreement, and I don't know what I can say. All I can say is I have been convinced by the experiments that there's just no evidence of wave. There's no evidence that a photon gets tired, that it's spreading, that it's affecting things in all different places at once, that any of that crap is happening. The evidence clearly demonstrates, even the two-slit experiment, that one photon goes to one location. It makes one little dot on a location. It ends up in one single place. It doesn't spread over everything.
I believe that the speed of light, or the correct term is velocity. The velocity of light is, or velocity of energy, as some people correctly put it.
Force. The velocity of force.
Some of you out there think it's the rate of induction. Well, you're only half right. It's a combination of capacity.
I suppose you should, if you're going to do this video thing, you got to talk to who you're talking to, because, you know, somebody could get the impression you're talking to them when you're not. See, maybe you're not talking to me right now. You're talking about somebody else. So it's not very helpful.
And inductance. You can't have one without the other.
This capacitance crap, I think that's what he said, right? I'll do it again, but it's just nonsense. None of that crap is happening in empty space. There's no capacitance and inductance in empty space. It's just, you know, I mean, the abuse of these concepts. I mean, capacitance has a real meaning, okay? It has to do with the number of atoms capable of holding a charge. That's the capacitance of something, is how many atoms are you able to affect with charge, to put a voltage on them. That's capacitance. You know, nothing else.
Unless if you do enough study. So what we've got here is, let's get another paper. Here we've just had a bit of a scratch pad. This is calculating the number of photons in a 100-watt red light bulb at 650 nanometers.
Again, I don't even know why he would do that, right? A red light bulb. And again, you're not going to be counting anything called the number of photons, because you can't. Because what we consider to be a photon, okay, is something that has to affect an electron and create a voltage. So you're not going to be able to measure the total real amount of energy, because there's going to be a portion of the energy that's not going to be in a form you can detect. So, you know, it's going to be in a form of like gravity. And as I've pointed out before, if you had to calculate gravity, if you had to make a laser light that pushed this pen 10 inches this way to equal the same amount of force that gravity is applying here, it would have to be a gigawatt laser just to do that. So there's gigawatts of energy clearly right here. This.
With 3.272 times 10 to the 20th power number of photons. and the frequency is 461.
You know, what's the point? Again, this is just you know, you can't make these explicit calculations. So, and what's the point of doing it? We know that a certain voltage went in. We know there's a certain efficiency of the light bulb in producing photons out. Now, for some filaments, okay, the amount of heat is 80 or 90% of what's produced instead of light. So clearly you're not going to produce these red photons in the same amount as with the voltage that went in. So what are you proving with this non-interesting crap? Because it's just crap. Because we know that you put 100 watts worth of energy into the circuit, you know you're not going to get 100 watts of light out. To get 100, you know, it's just not going to happen.
22 terahertz, and the photonic energy is 3.056 times 10 to the negative 19th joule seconds per photon. And when you work out this number of photons on a surface sphere, 1 billion kilometers radius, I think that was about, I think it was 55 minutes roughly.
Again, what are you doing? Who are you talking to? What is this? What is the purpose of this mush? What do you think this demonstrates? You go in with certain assumptions about how much energy is in a photon, then multiply it by how much voltage you put in, and say you have defined the energy transfer. And as I've just pointed out, well, if you didn't count the heat, then you're already in trouble, right?
In light travel time, you end up with one photon for every 38 meters, 38 square meters per second. That's one photon hitting a 38 square meter area every second at that distance. So
yes, at this big huge distance, right? So what? Again, how is this interesting?
Inverse square law. Look at that here. With transverse electromagnetic waves, you end up with field rarefaction. The field.
So now we got Ken Wheeler bullshit. Field rarefaction. Now, what could that possibly mean? TEM equals field rarefaction. What could that mush mean? What is those? What are that mushy word? What does rarefaction mean? What? It sounds almost like some sort of holified, like God rarefied it. He cleansed it of sin. Is that what the field has been cleansed of sin? What the fuck could that possibly? What could that mush mean?
And thinner as the distance increases, according to this inverse square law. This has been known for hundreds of years.
Yeah, that's right. Newton well established that the orbiting planets are obeying the inverse square law. So now we can be done with it. It was already demonstrated. Clearly it works. It answers the question. It explains what kind of velocity will require to overcome the force and what the force is by the velocity. So it just answered all the questions. So we're done. We knew how many times the Earth goes around and figure out the distance, and then you got the answer to what kind of counter force there is, and it equals the inverse square law. So we've already answered the question that that's how the force is coming in. It's coming in evenly from the outside will create the inverse square law. So if you make a pressure even on the outside, a vessel of pressure, it will create the inverse square law for every little single point source you could create inside that pressure field. The inverse square law is the definition of spherical. Okay, that's what spheres do. Spheres spread in 2 dimensions.
I think Da Vinci was the actual first person to do this with his study of chiaroscuro, the study of light and dark. He was very good, Da Vinci, very smart man. So what we end up with, the inverse square law applies to photons, but you get a decreasing...
It applies to anything, okay, that's diverging in 2 dimensions. Anything that's getting bigger in 2 dimensions.
Photons per square metre. It's that simple. The other one, you end up with a decreasing field strength. Very simple.
Yeah, very unsaying. You're not saying anything. You're certainly not correlating it to a single experiment known to mankind. So why should this mean anything to me? What neurons do you think you're going to fire and say, oh yeah, field relification? When again, I can't even comprehend what I need this stupid field for. What do I need the field for? What is the field's purpose? The photon goes from point A in every real experiment we know of. The photon goes from point A to point B in a dead straight line at a dead constant speed. What do I need an asshole field for?
Now, some of you people out there, you know, you get led astray. You're too lazy to do the study or the research yourself.
Well, you know, everybody can just say, I'm rubber, you're glue, buddy. So again, we're just back to this, you know, life experience thing. And so apparently you think you've done the proper number of experiments and you've been electrocuted the proper number of times to know how the damn thing works. And I'm going to argue I've done that. And stalemate.
Some of you people are very interested. Some are very studious or studious. I'll put it here somewhere. Yeah, just you can start with a reference of standing wave ratio, and then you could go into...
Why would I do that? What is standing waves? Again, standing waves only have any meaning in mediums that have tension, and without them there's no such thing, really. You can't, you know, it's not a real phenomenon. You can't put a standing wave in empty space. Looking at
the energy of the photon, and the photon, it has no mass, but it has...
Well, it obviously has some kind of capacity to transfer momentum, so it would be kind of silly to say it has no mass. It's kind of an empty statement. It has momentum. It transfers it from one place to another, clearly. Photons make things hot. Photons move things. Photons do work. Can't really do work if you got no arms and legs, so to speak. It's got to have some kind of mass.
A mass equivalent. It has a kinetic energy equivalent.
Same difference then, right? So why aren't we just saying, oh, it has mass, whatever, half mass. You know, let's just make up some jerky jargon. It clearly has the capacity to transfer momentum, and let's just, you know, call it mass number 1. It's the smallest bit of mass. There.
Transfer energy from one side of the galaxy to the other without losing power. We can go, not only the galaxy, the universe, you can detect photons billions of years old. No.
Right, and if I put something in their way, I won't see them. You know, so they're not magical. We know they're traveling in a straight line because I know if I put something in the way, I'll block the damn thing.
Wave in the world is going to do that no matter what power you use. A photon can travel from one side of the universe to the other and still have the same rotational velocity.
All right, this rotational velocity. So where'd you get that from? Where did you invent this? What evidence, what experiment shows me that photons are rotating? Every piece of evidence indicates that you can't tell one photon from the other, in a sense. You know, the actual energy corpuscle. So why are we inventing rotations now?
You'll have the same little quanta of energy without loss. And that to me is just amazing. But anyway, this little video is...
Well, clearly the bulk of the photons, okay, there is loss. They are hitting something and never getting here, like a laser beam over distance. The little photons hit dirt and fly the wrong way and blah, blah, blah. So there's lots of degrading of the energy over distance.
Just my point of view. It's all provable.
All right, well, that's the interesting part. It's all provable. That's what you sort of have to do for me, right? So you can make assertions about some sort of rarefication, but show me something getting rarefied. Show me your evidence that there's, oh, this is the only possible explanation is rarefication. Well, show me the experiment that says this is the only possible explanation.
I'm really disappointed at the level of stupidity that I see on the internet. It's really, it's just mind-numbing.
Yes, it's depressing. and yeah, and it's hard to figure out who the extent of the blame for how the conversation is degraded, and why it has to be this, why it is this bad. But I guess I'm arguing that some aspects of it, you can see that they're just cowards, they're fanatics. So you could argue that most of the conventional camp are afraid to be interrogated, because they don't have rational answers. You can just keep pointing out how bent space is an empty answer. That's just saying Santa Claus did it. It's like saying nothing. It's not a physics answer. You're giving no mechanical device whatsoever. Just saying whatever. The goo did it. The magic goo. It's nothing. Virtual photon, what is that? Borrowing from the vacuum? Why are these rational statements? They should be irrational statements.
You know, a few of you guys, I've tried to open communications with yous. You think I'm some sort of nutcase or a crank. I don't care. Whatever you think's irrelevant. I just care about the true facts.
Yeah, exactly. But if I took you seriously and said, okay, I'll take that as a serious statement. You just care about the facts. But is that what you're doing? Is demonstrating why it's a fact, or are you just asserting it's a fact? That's the problem. I want to argue experiments, because that's all there really is the experiments. That's where the truth lies. The experiments have the truth in them, and it's just our misinterpretations, our conflicting interpretations of what the experiment is saying. Again, we go back to the two-slit experiment. Totally unremarkable in the context of Newton. Newton already did the single slit and he already did the single hair. So in a sense, this experiment, it had already been done in two variations that sort of gave you the complete answer. And I mean a complete demonstration of the phenomenon, of the fact that you get this bizarre pattern. So we already knew about it. Young, totally unremarkable. And then what does physics do with this? They turn this into this magical phenomenon, right? So they have this circumstance where the simplest, tiniest thing that we know of, a photon, goes into this machine, this device with slits in it, right? This complex material thing. And they talk like, well, yeah, it's like bouncing a ball off a table. So they know that atoms are made out of these shells and all kinds of swirly bits and all this bullshit, and then they talk like, well, yeah, no, but when a photon hits matter or goes by matter, it's just like hitting a table. And they'll show you a picture of atoms with swirly bits and all this kind, you know, well, there's mostly empty space. Well, a table isn't mostly empty space, is it? So I mean, they use these just completely nonsensical metaphors. And you're saying, well, maybe you're not getting it. Maybe the complex thing is the matter you're forcing the photon to associate with. That the biggest feature of the smalling slit, the fact that you're making it smaller and smaller and smaller. What's happening when you make it smaller? Oh, that's right. The odds of it that having to go right next to the surface go up and up and up. So the smaller you make the hole, the likelihood that the photon went right next to some matter goes up and up and up. And so maybe the matter has something to do with why the photon gets distorted or perverted. I mean, the fact that they won't even consider these interpretations is... That is something worth saying, okay, this is where the conversation is broken. That these arrogant douchebags are asserting a truth, and here they are, and they seem to always go for the extraordinary explanation. Create a new universe, create new matter, dark matter, this, that, all this super energy. They even have a quasi-particle now. They actually have the word quasi-particle. I mean, yeah. So they don't want a simple answer, a rational answer. No, just give me unicorn. Give me sequins and fairy dust and little sparkly magic wands. Forget about physics.
You can take these. You can take anything here and see what I've worked out. You can freeze the video. You can analyze it. You can call me.
Yeah, okay, there's nothing to analyze, okay? You haven't established anything as a truth here anywhere. Nothing you've said has any truth value because it's not connected to anything observed or in any way actually measured.
Or whatever you want. It doesn't matter. I will still sleep at night. I'll still have my cup of coffee. It doesn't matter.
Well, it does matter. So again, you know, we can all say, well, you can't get to me. Yeah, well, they're not going to get to me because I've already been gotten to. I mean, I've already been revolted and disgusted. So, but I'm just saying it is frankly disappointing that there's no capacity to have something called a rationally bound conversation. Everybody's irrational and full of crap and truther fanatic.
You call me a nutcase or a crank, and really, you want to have a look at your own videos and just see how you come across to other people. And
well, frankly, I do watch my own videos all the time. It's my favorite video producer is me, and I find them very sincere efforts to explain things as simply and logically, and this is what it looks like, this is what it calculates like, this is what it adds up to. It really can't be seen any other way because it fits too well. I mean, the way I'm putting these puzzle pieces together, I don't have to glue anything with any dark matter, and I don't have to glue them with any virtual photons, and I don't have to do any of that crap. It all kind of just fits together. Once you understand that it's the speed of force, and once you understand light isn't any kind of special force, it's just one of the forces, one manifestation of force, a tiny percentage of the force in the universe. Not complicated.
For some people out there, they mention extra deities, or they mention that they've travelled into the future, or just plain bullshit. Just stop your crap, come up with some figures, come up with some facts, and
again, I don't think figures are going to be the new physics. So again, the figures have already been done. I mean, they're just descriptions of effects. Again, you're not... Maxwell's equations, I think, need one more rendition just to get rid of the E and B fields because it's just stupid. They don't need to exist. There's one force, and all you have to do is understand that you know, monopoles behave different than dipoles. They affect the universe differently.
Yeah. I won't be wasting my time watching some of you people. I've actually unsubscribed from some of you people because you're just full of crap.
I think you ought to name names. Again, it's just kind of silly to put us all in some kind of category and I'm supposed to figure out, are you talking to me? Are you talking to me? Am I supposed to figure that out on my own?
Anyway, to the rest of you, you have a nice day. This is Rob Ritchie. We might be watching some of your videos later.
All right,
Good day, viewers.
I thought there was a little bit
This
in
video.
there. I thought there was a little bit in there where he said something about radio waves not being able to go through space or something. So I must have talked over that a little bit, or I paused in the middle of it or something. But I just wanted to point out to them that there's lots of radio antennas. Clearly, we're picking up radio waves from tens of billions of light years away, kind of thing. You know, to 10 billion light years away. So clearly, the radio waves are just as durable as the photon waves. They make out just fine. Alright, so I think that's it. Yeah, I think it is. Okay, so let's see if there's any new comments and then we'll toddle off. So anyway, yeah, so he seems like a nice enough guy, right? But yeah, maybe he's cracked, you know, maybe. You know, I mean, obviously he has these, you know, a little bit of a weirdness here with Hathaway. He's misinterpreting Hathaway. Like I said, he's getting that he's an asshole, but he's not getting what kind of asshole he is. He's misidentified him as a, you know, it's like calling a rabbit a reptile or something. He's getting it wrong, but it's not entirely wrong. So yes, you know, but you know, and again, the point where somebody goes far enough afield, far enough out there, where they finally say something where you say, yeah, you're just too stupid or you're just too crazy. And so, maybe he's going to do that eventually, and I'll just say, okay, I just can't. There's no point in the conversation. But clearly, we have such a fundamental disagreement about how the universe works. I just don't see the point. Maybe we have a common enemy in conventional physics being full of crap, but clearly it seems to me that you're accepting some of their crap. Their silly, double wavy crap. So anyway. Oh, yes, there it is in my... Yes, well, now I've subscribed to his channel, so yeah. It should be there, because I subscribed to it. Alright, so that looks like that's it. Alright, so enough of a video. It's probably more than enough, but... you get what you get. Bonus, we'll just call it. So anyway, till the next time, and such, so forth and whatnot. Yeah, I think that's all. Did cover a lot of stuff, I think.